In this video, I'm going to solve two such questions based on factorization of polynomial. The question says that, write what are the possible expressions for the dimensions of a cuboid whose volumes are given. So over here, we know the volume of a cuboid and we have to find out the possible dimensions. That means the length, breadth, and height. So what you already know that, let's say, for example, if you say that if you know the volume of any figure as say cuboid is 30, so it's possible length, breadth, and height, right? You have to split into three factors. Like say, for example, I can say this is 5 into 3 into 2, right? Say this be length, this be breadth, and this is height. As you can see, the volume of a cuboid is length into breadth into height. So that means when we are given the volume of a cuboid, then we have to find its dimension, that is say length, breadth, and height. And how do we find out? By splitting them into three factors. So this is what we have to keep in mind in a question like this. Let's say if I do the first one where we know the volume as this, like over here, the volume is given as 3x square minus 12x. So what we have to keep in mind is we have to factorize it into three factor, exactly three factor. So as for the method of factorization is concerned, first thing that we try figuring out, is there anything common? I can see there is common. So I can take 3x as common. Taking 3x as common, dividing this by 3x, right? If I divide the first term with 3x, we'll get x. And if I divide this 12x by 3x, we will get 4. So what you can see here, I can write this as 3 into x into x minus 4. You can check, we got three factors, right? 1, 2, and 3. So this is what you have to keep in mind, that we have, if the volume of a figure is given and if you are asked to find out its possible dimensions of length, breadth, and height, we need to factorize it into three factor. Now check for the next part. In next part, this is the volume given here. So if I write this is 12 k times y square plus 8 ky minus 20k. Now, same as the previous part, we are going to split them into three factor. As usual, we will look for a common. I can see that from 12, 8, and 20, we have 4 as common. I can see even k is common, so I'll take k as common. Now, this becomes, on dividing with 4k, I'm getting this as 3k, right? 3 times y square. Dividing this with 4k, I'll get 2y, and dividing this by 4k, I'll get simply 5. Now, the next thing we are going to do is to factorize this further. And as you can see that this is by that I mean to say, I'm going to factorize this quadratic polynomial further. As you can see, this can be done using middle term splitting. So we have to, from the factors of, from the factors of 15, I have to get, now this is clearly 5 minus 2. I can see that 5, the rule is we multiply coefficient of square term with that of constant. So 3 into 5 is 15. From the factors of 15, I have to get 3. So clearly I can write 5 into 3, and 5 minus 3 is 2. So this is what I'm going to split here. I'm going to split 2y, right? I'm going to split this 2y here. Let's say this is 3y square, and I'm splitting this 2y as 5y minus 3y, and then minus 5 is copied. Now check, we have 4k already. So we can take from here, I can see y is common, sorry. So on dividing with y, we'll get 3y plus 5. Later, I can see from the last two term, minus is common, or say minus 1 is common. So if I divide by minus 1, I'll get positive 3y and positive 5. Now check for the remaining part. I can see 3y plus 5 is common throughout. So we can take 3y, but not before writing 4k outside. and then I'll take 3y plus 5 as common, and then this is y minus 1. So you can see that we got three factors. Let's say this is 1. Let's take this the second. So we can say that we have split them into three factors. So these can be the possible values of length, breadth, and height. So we'll say the dimensions of the figure without specifying which is length, which is breadth, which is height. Therefore, the dimensions of the cuboid will be 4k, 3y plus 5 and y minus 1.